Thank you, Sam. Hello, everyone. My name is Vaibhav Singh. I work with BMC Discovery support team. I'm specialized in discovery, Helix discovery, as well as integration between discovery and other products. Welcome to the part 2 of BMC Discovery and BMC Helix CMDB integration. Before we start with today's session, let's take a quick recap of what all things we have discussed in the part 1 of this webinar series. In the part 1, we talked about what is BMC Discovery and what is BMC Helix CMDB. We also discussed the data store and the data model used by these two products. We saw end-to-end data flow in IT operations and service management. Specific to this integration, we talked about prerequisite, common data model mapping, local shadow copy, and a step-by-step process of this integration. We briefly talked about what are the services and logs specific to this integration. And we had a demo where we saw how to create this integration connection from the Discovery UI. Now let's start with the agenda for today. We will start by understanding the types of discovered data. And then we will talk about the types of data inconsistency between Discovery and CMDB. We will then talk about troubleshooting approach and tools, and we will take a deep dive into two of the most used tools that are shadow copy and logs. We will also see how to customize this integration, and at the end we will talk about few of the common issues with their suspected root cause and solution. Let's start and understand the types of discovered data. In the part 1 of this webinar series, we saw that when we have servers, devices, or other configuration items that we want to discover and track in CMDB, we will first deploy BMC Discovery Appliance. And though BMC Discovery Appliance has the capability to discover all types of CIs, in most cases we will deploy BMC Discovery Outpost. Discovery Outpost will connect to Discovery Appliance and pick up any scanning request that is triggered by a Discovery user or through some API calls, and they will connect to the target endpoints, which include servers, devices, and perform the discovery. The Outpost will then capture all the information from the endpoints and transfer that information to the Discovery Appliance, where the data will be stored as directly discovered data. The directly discovered data or D data includes all the data that Discovery Appliance or Outpost collect from the target endpoints. An example of this data would be all the running services, all the packages that are found on the target endpoints. Once the D data has been collected, Discovery applies its own reasoning on top of this data and creates another type of data that is known as inferred data. An example of that would be all the host nodes or all the software instances node, etc. Once all the D data is converted or inferred into the inferred data, a part of the inferred data which is relevant from IDL perspective is converted into common data model and synced to the CMDB. A copy of the data which has been sent to the CMDB is also stored in the local shadow copy. So the important point to understand here is that not all the discovered data will be synced into the CMDB. Discovery first collects all the data in the D format, then it applies the reasoning on top of it to create inferred data, and only the part of the inferred data is synced into the CMDB. Now that we have understood the type of discovery data that gets synced into the Helix CMDB, let's talk about data inconsistency that you might see when comparing discovered data with the data that has been synced into the Helix CMDB. I'm going to talk about all types of data inconsistency that is reported by customers. And you will see that some of these are not exactly data inconsistency, but the design behavior. In terms of BMC Discovery, so far we have talked about two important components. One is the BMC Discovery data store, where we have the directly discovered data, inferred data, and other types of data stored. And the second component is local shadow copy, where we store a copy or replica of the data that has been synced into the CMDB. Similarly, in terms of BMC Helix CMDB, we talked about two important data sets. One is the Discovery import data set, which is by default BMC.addm, and the other one is the prod or asset data set. In the previous slide, we saw that not all the discovered data will be synced into Helix CMDB. So if someone compares the data that is available in the discovery data store with the CI data that is available in the discovery import dataset in Helix CMDB, a data difference or inconsistency is expected. Similarly, if somebody compares the data that is available in the discovery data store with the CI data that is available in the discovery local shadow copy, which basically stores a copy or replica of the data that has been synced into the CMDB, then again a data difference or data inconsistency is expected. But if you see inconsistency when comparing the data that is available in the shadow copy with the data that is there in the import dataset, then that would be a valid inconsistency, because the local shadow copy, it stores a copy or replica of the data that has been synced into the CMDB. So in ideal case, the CI data that is available in the local shadow copy should be same as the data that is available in the discovery import dataset in Helix CMDB. Similarly, when you are comparing the CI data that is there in the import dataset with the CI data that is available in the prod or asset dataset, and you find a difference, then that could also be a valid inconsistency, and that needs to be investigated by the CMDB admins or CMDB support. So to conclude, a valid data inconsistency would be data inconsistency between the data that is available in the local shadow copy of Discovery and data that is available in the Discovery import dataset in Helix CMDB. In coming slides, we are going to talk about troubleshooting approach tools to make sure that we maintain data consistency between the shadow copy and the data that is available in the import dataset. Let's start with troubleshooting approach. There are three types of issues that you might face while working with Discovery and CMDB integration. The first one is connection or network issue, where Discovery cannot connect to the CMDB when using the connection type AR or CMDB API or CMDB REST API. The second issue is that where Discovery is able to connect to the CMDB, but while syncing, we are getting some errors. These errors could be specific to one CI type or could be happening for all the CIs that we are trying to sync. And the third one is data inconsistency. For the first issue, that is connection or network related issues, first we need to identify the error code or error message, and based on that we will identify or we will use one of the troubleshooting tool to analyze the issue further. For the second issue, that is errors while syncing the CI to the CMDB, again we will identify a troubleshooting tool to analyze the issue further. For the third issue, that is data inconsistency, first we need to determine whether the inconsistency is valid or not. We can use the concept that we discussed in the last slide to answer this question. If the answer is no, that it is not a valid inconsistency, then either there is no issue or you are looking to sync something which is not supported out of the box. In that case, you can request BMC to include the sync of that new information in the out of the box sync mapping, or you can write a custom pattern to sync that information into the CMDB. However, if the data inconsistency is valid, then again we will identify a relevant troubleshooting tool to analyze the issue further. Looking at this flowchart, we can clearly see that to troubleshoot any type of issue, we need to identify the troubleshooting tools. So let's talk about what are the troubleshooting tools that we have available. To troubleshoot Discovery to CMDB integration related issues, we have three types of tools available. The first one is CMDB synchronization logs, which we can use to troubleshoot all three types of issues, that is connection network related issues, errors while syncing the CIs, as well as data inconsistency. The second tool is local shadow copy, which is mainly used when you are troubleshooting data inconsistency related issues. And the third one is CMDB API client side log. This is very rarely used, and you only need to enable this kind of log when requested by BMC support. Also, this is only applicable when you are using AR API or CMDB API type of connection to integrate these two products. If you use the recommended CMDB REST API type of connection, then this type of logging or this tool is not applicable at all. As this is not a very commonly used tool, I'm not going to go into details, but if you're interested and wants to know how to enable this type of logging, you can review the K that I mentioned here. You can also find a link for this K in the reference slide of this presentation. In coming slides, we are going to focus on the first two tools, that is CMDB synchronization logs and local shadow copy. And we will see how these two can help us to troubleshoot all types of Discovery to CMDB integration related issues. Let's start with the CMDB synchronization logs. In the part 1 of Discovery CMDB integration webinar, we briefly talked about these logs. But just to recap, we have 3 types of logs available on the Discovery appliance that we can review to troubleshoot Discovery to CMDB integration related problems. The first log, that is connection test, as the name says, captures the details when we test the Discovery to CMDB connection. The second log, that is exporter log, captures the export related details when we are using CMDB or AR API type of connection to integrate Discovery with CMDB. And the third log, which is transformer log, captures the details of the CDM mapping as well as each stages of the integration. The transformer log is the most important one out of these 3 logs. From this slide, what I want you to keep in mind are the 5 stages of the synchronization that we discussed in the part 1. These stages are selecting a root node, building a source subgraph, then converting the source subgraph into target subgraph, then comparing the target subgraph with the target subgraph that is stored in the shadow copy, and finally syncing the changes into the CMDB. Because in few minutes, we are going to take our first demo where we are going to review the transformer log. You will see all these 5 stages getting captured in the log. Before we start with our first demo, let's quickly talk about the shadow copy as well. This is something we did discuss in the part 1, that shadow copy was introduced in Discovery 10.2. It stores a copy or replica of the data that has been synced to the CMDB. Discovery creates one shadow copy per connection, and we have a knowledge article which we can refer to query the data that is stored in the shadow copy. Now let's take our first demo to see how we can use the log and the shadow copy to troubleshoot different types of Discovery to CMDB related problems. For this demo, I've already logged into the Discovery and CMDB UI, and we are going to take 3 scenarios to understand how to review the log and how to query the local shadow copy. The first scenario is that we have a server CI which has already been synced to the CMDB, and to confirm this, let's take the name of the CI and go to the CMDB, and we are going to search in BMC underscore computer system class, because from the CDM mapping we know that server CIs are going to be mapped into BMC underscore computer system class in CMDB. So let's search for the server CI here to make sure that it has been synced from Discovery to this particular class. After adding the CI name, I'm going to select the dataset that we have used while creating the integration connection from Discovery to Helix CMDB. So if you recall from the demo that we have in the part 1, we have used this particular dataset. So I'm going to select the same and search for this CI. So the scenario 1 is that we have a CI in Discovery that has been synced to the CMDB, and we are able to find that CI in BMC underscore computer system class. In a minute, I'm going to explain what we are going to do in this scenario. But for now, let's look at the scenario number 2. In the scenario number 2, we have a different server CI which has not been synced into the CMDB. Let's quickly confirm that. Copy the CI name from here. Again, go back to the CMDB portal and do a new search. And we can see there are no CI matching this name in CMDB. And for the third scenario, I have taken a server CI which has been synced into the CMDB, but there is a data inconsistency. So let's search this CI in CMDB and see what kind of data inconsistency I'm talking about. Again, I will do new search, add the CI name here, and change the dataset ID to our dataset, and search. From the CI details in CMDB, we can see that the serial number of this CI is set from 1 to 9. But if we go back in Discovery, we can see the serial number is something different. So we can clearly see there is a data inconsistency. The serial number that is discovered in Discovery is not the same as the one that is synced into BMC Helix CMDB. A quick note before we start with all these three scenarios. If you're used to be searching CIs from CMDB new portal, then you can do that. And just to quickly show you, log into the CMDB portal, then you can select the data set like this. In our case, we are going to select our data set. After that, enter the required class name, then the attribute that you want to search and the attribute value. So let me quickly show you how the details are going to look in this new portal. From the search result, we can click on the CI name, scroll down and select the option show CI details. And this is going to show all the details that we just saw in the other view. From this view also, we can see that the serial number is set from 1 to 9. Having said that, let's start with our scenarios. First thing, we are going to enable the debug log for CMDB synchronization at the discovery end. So let's go back to the discovery UI. To enable the debug mode, click on the administration icon, then go to logs, and let's enable debug for the CMDB synchronization log. Hit apply and click on OK. Now our CMDB synchronization log is in debug mode. Let's go back to our scenario number 1. We have a host which has already been synced to the CMDB. We are going to sync it again and then review the logs. To sync this host again to the CMDB, we can simply click on action and then sync to CMDB. Let's go to the CMDB status page and make sure that this CI has been synced to the CMDB. From here, we can see that the CI sync status is set to OK. That means there was no problem. Now let's download the transformation log and see what all things were captured during the sync of this CI, which has been synced into the CMDB in the past. To download the log, again click on the administration icon, go to logs and click on log files. To quickly find the log, let's do Ctrl F and search with transformer and we can see the log right away. So let's download this and review it. I have opened the downloaded transformer log in Notepad++, and before we go into details and see what all things are captured for that particular CI sync, let me quickly highlight the stages of the synchronization again. So as we discussed, there are 5 stages of any synchronization. The first one is selecting a root node. The second one is building a source subgraph. The third one is converting the source subgraph into a target subgraph. The fourth one is comparing the target subgraph with the corresponding target subgraph that is stored in the shadow copy from the previous sync. And the fifth and the last stage is syncing the CI changes to the CMDB as well as updating those changes in the shadow copy. Now let's go back to the transformer log and try to find all these stages. To start the review of the log, we will go to the log and do Ctrl F and search with the CI name that we synced from Discovery to CMDB. Let's start with the first match that we can find here. Let me close the search result window. Here we are syncing the host type of node, which is considered to be a root node in Discovery. So a root node is already selected. So the next step would be building the source subgraph. And we can see the same thing happening here. So the Discovery Transformer service has started building the source subgraph. In this stage, Discovery goes into the data store and try to find all the relevant information for this particular CI. Let's scroll down and see where this stage is getting completed. Here it is. We can see that the source subgraph is now completed with the information about the nodes and the relationship related to this particular CI. The next stage would be to convert this source subgraph into target subgraph, which basically means converting the data into common data model. And we can see that that stage is starting right here. The target subgraph or the common data model mappings happens using the sync mapping patterns. So we can see that Discovery is now going to use all the sync mapping patterns to transform the source subgraph into a target subgraph. One sync mapping pattern we can see right away that is related to computer system CI. If we scroll down, we will see details of all the sync mapping patterns that are applicable for this particular CI getting triggered and the transformation of the data is happening. So let's keep going down and see where this target subgraph is getting completed. And from here, we can see that the target subgraph is now completed. Now the next stage should be comparing this target subgraph with the corresponding subgraph that is stored in Discovery shadow copy from all the previous sync of this CI. And as we already know that this CI has been synced from Discovery to CMDB in the past, so there should be a target subgraph stored in the shadow copy. So let's see what is happening in the next stage. And here we can see that the fourth stage has started. The transformer service is now reading the shadow copy to compare the target subgraph that has been prepared with the target subgraph that is stored from previous sync. And as a result of this comparison, what we can see that Discovery has identified that there are no changes on the computer system CI. So the target subgraph that is prepared during this sync is same as the target subgraph that is stored in the shadow copy. This means there is no change in the CI data and Discovery is not going to update computer system CI in the CMDB. Same details we can see for the other classes as well. For example, BMC underscore software server, we can see there is a software instance that is unchanged. Discovery will keep on comparing all the target subgraphs with the corresponding subgraph for a particular class that is stored in the shadow copy. And only when it identifies that there is a change in the CI data, that change will be sent to the CMDB. Otherwise, the process will terminate at the fourth stage only. If there are no changes, then Discovery will not commit any changes into the CMDB or in the shadow copy. So from this scenario, what I wanted to show you that how to review the transformer log, keeping all those 5 stages in mind, because this can help you to identify in which stage Discovery is having problem while syncing the data into the CMDB. Now let's go to the scenario number 2 where we have a CI which has not been synced into the CMDB. We are going to sync that. And for that CI sync, when we review the transformer log, we will see the stage number 5 happening, that Discovery is going and syncing the changes or the CI information into the CMDB. So let's go back to the Discovery UI and sync the host or CI that we have taken for scenario number 2. For the scenario number 2, this is our CI name. So let's click on action and sync this to CMDB. Let's quickly go to the CMDB sync status page and make sure that this CI has been synced to the CMDB without any errors. And from the CMDB sync status page, we can see that the CI has been synced to the CMDB and there are no errors reported. Again, I'm going to download the transformer log and show you what is happening in the stage number 4, because this time Discovery should be able to identify that this CI is not present in the shadow copy or in the CMDB and it needs to be created at both the places. I have opened the downloaded transformer log, and to see the details of our CI, let's do Ctrl F and search with our CI name. This time, instead of going and checking all the stages, I will directly jump to the stage where Discovery is comparing the target subgraph with the corresponding subgraph that is stored in the shadow copy. So from the search result here in Notepad++, let's scroll down and look for that stage. We can see that a stage here, so let's click and see what's happening. And this time we can see this information that this computer system CI needs to be created. That means when Discovery compared the target subgraph with the corresponding subgraph in the shadow copy, it did not find anything. We can find the similar details for other classes CIs like software server, BMC underscore product classes, and we will see that Discovery is now going and reporting that each of these CIs needs to be created. So this is the stage number 4, where after comparing the data, Discovery has identified that it has not sent the data into the CMDB, or whatever data it has sent, there is some change on that data that needs to be updated or created into the CMDB. From these two scenarios, we can clearly see that Discovery is using the local shadow copy to take the decision whether it needs to make any changes into the CMDB or not. And this is why the shadow copy becomes very important when we are troubleshooting data inconsistency problem. And that's our scenario number 3. So let's go back to the Discovery UI and see how we can use the shadow copy to troubleshoot the data inconsistency that we discussed for scenario number 3. This is the CI for our scenario number 3. And what we know about this CI is that in Discovery, it has a correct serial number, but in CMDB, for some reason, serial number is set to 129, which is obviously incorrect. So we need to figure out what went wrong and why an incorrect serial number is set into the CMDB. From the scenario 1 and 2, what we have seen that whenever Discovery syncs something to the CMDB, it always stores a copy of that data into the local shadow copy. So if we query the local shadow copy and see all the information that Discovery has sent for this particular CI, then we can quickly identify whether it is Discovery which has sent the incorrect serial number, or is it something else that has gone wrong at the CMDB side. To query the shadow copy, I'm going to use the knowledge article which you can find in our community. I have also mentioned this knowledge article in the reference slide of this presentation. Let's scroll down and see how we can use the steps from this knowledge article to query our shadow copy. In the knowledge article, from here we can see the steps. And the first step is that we need to identify the shadow copy for our connection. As I have highlighted, that Discovery creates one shadow copy per connection. So if you have multiple CMDB connections, then you need to identify the shadow copy corresponding to the connection that you are troubleshooting. So let's copy this query and run it from the Discovery UI to see all the partitions, and out of that we are going to copy the shadow copy partition for our connection. To run the query, click on Explore, then Query, and paste the query that we copied from the knowledge article. Let's run it. From the results, we can see multiple partitions. We are going to look for the partition which is matching our CMDB connection name, and that's this one. So let's copy this and open the query tab in new window again. Let's go back to our knowledge article. The knowledge article is having a detailed explanation about how you can query a particular CI for a particular class, or how you can look for a CI attribute in the shadow copy. For our scenario, we need to query the BMC underscore computer system class where the CI name is matching with the CI that we have synced from Discovery. And we want to see the details of the attribute serial number. So let's look for a query which is matching our requirement. Here we have a query that can fulfill our requirement, because in this query, we are searching in the BMC underscore computer system class, and we have a filter to filter the CI based on the name. And then we are also printing details like serial number and the name of the CI. So let's copy this query and add this into the second tab of the query that we have opened. The first thing that we need to do here is to change the shadow copy partition name. So let's copy the shadow copy partition that we got from the first query, add it here. And the second thing that we need to change here is the CI name. Next, I'm going to change the filter condition here from matches to has sub word, because we have not copied the exact CI name. The exact CI name would be fully qualified domain name, but here we are just using the name of the host node. So to make sure that query is able to find the CI information, I have changed the filter condition from matches to has sub word. Now let's run this query and see the details. From the query output, what we can see that for this particular CI, Discovery has sent the serial number that we see in Discovery. This means something has gone wrong at the CMDB side. And what exactly has gone wrong? To demo this scenario, I have logged into the CMDB, went into the Discovery dataset, and I had manually changed the serial number to 129. So what can we do to fix this problem? Because if we sync this host again into the CMDB, Discovery is going to compare the details with the shadow copy, and it will say there is no change in the CI data, so it doesn't need to update anything into the CMDB. Because whatever changes we have done that at the CMDB side, and Discovery or the shadow copy is not aware about those changes. So no matter how many times we sync this CI to the CMDB, it's not going to fix the serial number problem. If you see this kind of data inconsistency, and it is happening for a lot of CIs, then the best option is to run a full resync. In that way, Discovery will compare the shadow copy data with the data that is present in the CMDB import dataset, and it will correct the data right away. But if you see this problem for just, let's say, couple of CIs, then the best option is that you destroy that CI in Discovery, and Discovery will do mark as delete equals to yes in the CMDB. And then you rescan the CI again in Discovery. This way, Discovery is going to recreate that CI into the CMDB, and it will correct the serial number in this case, or if you have any other type of data inconsistency. So if you have data inconsistency based on an attribute detail and it is impacting a few number of CIs, just destroy them and rescan them again. If the issue is happening for a lot of CIs, then consider running a full resync to fix the problem in one go. But if you want to make sure that this kind of data inconsistency should not happen at all, then you need to make sure that nobody is updating the CI records in the Discovery import dataset. Because keep in mind, Discovery dataset is designed for Discovery use only, and any manual intervention on the Discovery dataset will lead to these kind of data inconsistency, because Discovery is not aware about the changes that you are making in the import data set. Now let's talk about customizations. For Discovery to Helix CMDB integration, there are two types of customization that you may need to do. The first one is augmenting to CI details, meaning syncing something which is not supported by out-of-the-box sync mapping. And the second one is overwriting the CI details that are synced by the out-of-the-box sync mapping. Let's take a demo here to see how you can perform these two types of customization. I have created two patterns, one for augmenting to the CI detail and the other one is to overwrite a CI detail that is synced by the out-of-the-box sync mapping pattern. We are now going to switch to Notepad++, where I'm going to open both the custom patterns that I've created, and I'm going to explain those patterns in details and all the sync mapping blocks that I've used. I have opened both the patterns here. The first pattern is to augment to the CI detail, and in this pattern, I'm going to take a root node attribute, that is host attribute, and sync that to a custom attribute of the corresponding computer system CI. This first pattern is simple and straightforward, but I'm going to use this example to help you understand all the sync mapping blocks that you need to define when writing a custom sync mapping. And in the second pattern, I'm going to take a non-root node, which is database, and I'm going to change the name of the database CI using this pattern. Let's start with the first pattern and see how you can write a custom sync mapping. To start the custom sync mapping, the first thing that we should do is add some comments about the entire pattern module. This helps us or someone from our team to quickly review and determine why this pattern was created. Once we have added the relevant comments, we have to start by defining the pattern module. As you know, in Discovery, we have concept of pattern modules in which we include all the similar patterns together. So even if you are defining just one sync mapping pattern, we still need to define the pattern module. And the way to define the pattern module is to use the keyword TPL, then highlight the version of the TPL, then use the keyword module, and then give a name for the pattern module. You can give any name to the module, but make it something meaningful. After defining the module, the next section is metadata block. In the metadata block, two important things that you can define. One is the origin. In this case, as we are defining a custom sync mapping, the origin will be custom. And the second thing is the tree path. Tree path is a path or a structure in which this pattern is going to look once you have uploaded this from the Discovery UI Manage Knowledge page. Once I upload this pattern, I'm quickly going to show you how this is looking in the UI. After defining the metadata block, we should go ahead and import all the out-of-the-box patterns that we may need to refer in our pattern. There are two reasons why we need to import out-of-the-box patterns, and I'm going to explain those when we talk about mapping and body section of this sync mapping. Once we have imported all the relevant out-of-the-box patterns, we can start by defining our sync mapping patterns. And the way to define the sync mapping pattern is to use the keyword sync mapping and then give a name for your sync mapping pattern with the version for that pattern. After that, we need to add some description about this pattern, because keep in mind, the comments that we have added on the top are applicable to the entire pattern module, but the description that we are adding here is very much specific to this sync mapping pattern that you are defining within your pattern module. Also, descriptions are mandatory, and if you don't define them, the pattern upload will fail. Next, we have the overview block in which we can define tags which can help us to search our custom patterns from the Discovery UI. After defining tags in overview block, the next block is the mapping block, which is the most important block within our sync mapping pattern, because in the mapping block, we define our starting point or node, as well as we can traverse to other related nodes in the Discovery data store. Specific to our use case in which we want to take host attribute and sync that to a custom attribute on the computer system CI in CMDB, our starting point will be the host node in Discovery. There are two types of mapping that we can use. The first one is the root mapping and the second one is the extension mapping. To understand the difference between these two mapping style, let's open the out of the box pattern that we have imported here. Here is that out of the box pattern that we have imported in our sync mapping. Let's scroll down and see what kind of mapping is defined in this pattern. Here is the mapping section, and if you look at the mapping, you can see that the mapping is directly happening on the Discovery node host, and that is being imported as a variable host with a small h. Now, this type of direct mapping can only be done on the root nodes and not on the non-root nodes. So this is called as the root mapping. But in our pattern, we are going to use extension mapping. So let's go back to our pattern and see how I'm defining the extension mapping. In my mapping section, what I'm defining, that go to the out of the box pattern and take the variable which is already defined there. As we saw, that is host with a small h. And in my pattern, now I'm importing that as a different variable as my host. This type of mapping is called extension mapping, where you go and take one of the out of the box pattern and pick the node that is defined there. This is one of the reasons why we need to import out of the box pattern, because that will help us to define extension mapping within our sync mapping patterns. As in our use case, we are only looking to sync a host attribute to a custom attribute on the computer system CI. I don't need to traverse to any other related nodes within the Discovery data store. So I'm going to end my mapping here. So in simple terms, what we did in mapping, we picked up the starting node of the Discovery for which we want to update the data into the CMDB. Now let's start with the body section. In the body section, the first thing that we need to do is to pick the corresponding CI of our starting node. In our case, the starting node is host. So the corresponding CI would be computer system CI. And the way I'm picking that computer system CI is by going back to my out of the box pattern and then taking the CI name or variable that is being used by this pattern. Let me go back to the out of the box pattern again and show you this detail. In my out of the box pattern, if I scroll down and go to the bottom, I will see the mapping happening and the variable name that this pattern is using to create the CI in CMDB. And from this mapping, I can see that the name of the variable is computer system. So same thing, I'm importing from this out of the box pattern into my sync mapping pattern to have the corresponding CI for my host. And after importing that CI, I'm giving it a new variable name as my computer system CI. So from the mapping, we have the Discovery node, and from the body section, we got the corresponding computer system CI. So what is the next thing we can do is to take the computer system CI dot name of the custom attribute that we are going to create or we have already created, and on that assign the host dot attribute value. If I want to map more custom attributes, I can define them here. But for now, I'm just going to map one. I'm going to end the body section and then the sync mapping block. Now let's quickly discuss the second pattern that I've created to override the database name. As part of the out of the box sync, the database server name only gets synced to the database CI description, but not to the database CI name. So if you have a requirement that you want to include the database server name into the database CI name, then that can be done using an override pattern. Please note, I have designed this pattern keeping in mind that the database is running on a standalone database server. But if you have a clustered database, then pattern needs further improvement. So let's see how I have created this pattern. Just like the first pattern, I have added a comment about the pattern module, and then I defined the pattern module as well as the metadata section. After this, I'm importing the out-of-the-box database sync mapping pattern. I'm importing this out-of-the-box pattern to define the extended mapping as well as to pick the database CI that is being synced by the out-of-the-box patterns. After this, I've defined the sync mapping pattern with the description and the overview block. In the mapping section, I'm taking the variable database underscore node from the out of the box pattern, and this time instead of using a different variable name, I'm using the same variable that is there in the out of the box pattern. As our requirement is to include the database server name as well as the instance of the database software in the database CI name, I'm going to need the database software as well as the database server node as part of my mapping. So what I'm doing here, I'm traversing from the database node to the database software node, and from the database software node to the database server node. If you're new to Discovery and don't know how to traverse from one Discovery node to another, you can watch my webinar on Discovery query and reporting best practices, which is available on YouTube. Coming back to our mapping, after defining the starting point and the relevant nodes that I need, I'm ending the traversal as well as my mapping section. Next, let's discuss the body section. As we discussed in the pattern 1, in the body section, the first thing that we need to do is to pick the corresponding CI that we want to update. And the way to do it is by going back to the out-of-the-box pattern that we are importing for our mapping and picking the CI variable from there. Same thing I'm doing here. I'm going back to the out-of-the-box pattern, and then I'm taking the CI variable that this pattern is using to create the CI into the CMDB. And I'm importing that as a new variable that is my database CI. After this, I'm defining two more variables, one for the database node name and the other one is for the database node instance. While writing the sync mapping pattern, if you need to use the details or the attributes of the traversed node, then keep in mind those node can only be used in for loop. In this case, as I want to pick the instance of the database software and the name of the database server, I have to use them in a for loop, and that's exactly what I'm doing in the next section. I've defined a for loop, and then I'm creating another variable to take the instance name of the database software. And then I'm defining a if condition. I have defined this condition to make sure that the pattern is only going to update the databases which name contains SQL. After this, as I need the database server name as well, so for that I'm using another for loop, and then I'm picking the database name. And finally, I have all the details that I need to change the database CI name in the format or syntax that we talked about. So that's exactly what I'm doing here. I'm taking the database CI and I'm updating the name of the database CI in this particular format. And for the debugging, I have added a logging details here. After this, I'm ending all the for loops, body, and the sync mapping section. Now that we have discussed both the patterns, let's log into the CMDB portal and create a custom attribute that we want for our pattern 1. I have already logged into the CMDB portal, and to create the custom attribute, I'm going to click on class management and then on classes. To create the attribute, we have two options. Either we create the attribute on the root or top class, that is BMC underscore base element, or we go inside the specific class and create the attribute there. I'm going to create the attribute on the specific class, which is BMC underscore computer system. And to do that, let's search the class name here. We can see the BMC underscore computer system class here. So let's click on it. And to add the attribute, let's click on this option. We can see that the data type is already set to character. Namespace is already set to bmc.core. So only thing that I'm going to add here is the name of my custom attribute. I'm going to call it demo underscore serial. Let's copy this. I'm not going to make any other changes. This is enough for our pattern to work. So let's scroll down and save this. The attribute is now created on our BMC underscore computer system class. So let's go back to our pattern and add this attribute. I'm going to add the created attribute here. And then for the discovery attribute, let's take serial number. So just for this demo, what I'm doing, I'm taking the host serial number and I'm syncing that value into a custom attribute that we just created in CMDB. Let's save this pattern. Our patterns are now ready for the testing. But before we do that, we need to restart the transformer service because the attribute that we just created in the CMDB, Discovery is not aware of that attribute. That's a new change in the data model that Discovery needs to fetch from the CMDB, and that will only happen when we restart the transformer service. And if you recall from the part 1 of this webinar series, I explained how to start the transformer service using the TW service control. So I'm going to log into my lab appliance command line and I'm going to start the transformer service. I have logged into my lab appliance command line and I'm going to run this command to restart the transformer service. So let's hit enter. While the services are starting, you will see that Discovery is going to read the data model for all the CMDBs like Helix CMDB, ServiceNow CMDB, and it will come to know about the new attribute that we just created in CMDB. So you can see it's loading the data model. Please note, restarting the transformer service is required. Otherwise, the sync to your custom attribute is not going to work. Okay, now we are all set to test these two patterns. So let's log in into the Discovery UI and upload these two patterns. I have logged in into the Discovery UI. To upload the patterns, click on Manage and then Knowledge. And from this page, click on Upload. Click on Choose File and go to the location where you have saved the custom patterns. I'm going to upload these patterns one by one. The first pattern is uploaded. Now let's select the second pattern. The second pattern is also uploaded. Let's scroll down and see whether they are in the same tree path what we defined in the pattern or not. As we can see here, both of the patterns are uploaded and shown in the tree path that we have defined in the metadata block of our sync mapping patterns. Now let's take a database host and sync that into the CMDB, and then we are going to log in into the CMDB to check the details of the database CI as well as the details on the custom attribute, and we are going to see whether the serial number is getting synced on that or not. I have opened one of the database server. To sync it, let's click on Action and Sync to CMDB. Let's go to the CMDB overview page and make sure that sync is completed. We can see that the host has been synced to the CMDB. So let's go to the CMDB portal and check the details of the database CI first. I've logged into the CMDB portal again, and to search the database CI, let's first change the dataset ID to the dataset that we have been using. From the CDM mapping, we know that the database will be synced into BMC underscore database class. So let's change the class name here. And then let's search the entire database class to see what kind of CIs we have. From the search result, we can see two syntax or format for database CI names. One is matching with the one that we have added in our custom pattern, and the other one is following the out-of-the-box pattern structure. As we have only synced one host from the Discovery to test our pattern, all the databases which are running on that host got the new syntax that we wanted for our database CI. This confirms our pattern worked as expected. Now let's go and check the computer system CI to see whether the serial number is synced to that custom attribute or not. So let's change the class name to computer system. And then we are going to search with the CI that we just synced into the CMDB. Let's open this CI and click on Show CI Details to see all the details of this CI. Let's do a Control F and search with our attribute. And here it is. We can see that the demo underscore serial custom attribute that we created got the serial number that is set on the host node in Discovery. So the serial number gets synced to the out of the box attribute that is serial number. But in our custom pattern, we added the logic that use the serial number and sync that into this custom attribute that we created. Similarly, you can take any attribute that you have in Discovery which is not getting synced to the CMDB out of the box and write a custom sync mapping pattern to sync that. Using the concept that we have discussed, you can write sync mapping to augment to the CI value or to override the CI details that are getting synced using the out-of-the-box sync mapping patterns. This concludes the demo. Now let's talk about some of the common issues with their probable root cause and solution. The first issue is related to Discovery to CMDB connection test failure. And I've listed down a couple of error codes and error messages like error 1991, or error messages like authentication failure or error retrieving server details. The first probable root cause for this issue is that Discovery appliance does not have network connectivity to your CMDB server. And to confirm this, you can connect to the Discovery appliance command line and then use basic networking commands like ping and telnet to confirm that Discovery appliance can connect to the CMDB server or not. If Discovery appliance can connect to the CMDB or AR server, and you are using AR API or CMDB API type of connection for the integration, and you are getting errors like error retrieving server details, then you can check whether there are some performance issues on the AR server side. In addition to this, make sure that the details that you are adding while creating the connections are correct. For example, CMDB URL when you are using the REST API type of connection, or AR server address details when you are using AR API type of connection, and obviously the username and password that you are entering. The next issue is that CIs are destroyed in Discovery, but when you go and check those CIs in CMDB, you are still able to find them. The important point to note here that whenever CIs are destroyed in Discovery, Discovery does not do a hard delete on those CIs in CMDB. For the deleted or destroyed CI, Discovery will send a flag which is marked as delete equals to yes on the CIs in CMDB. And that will only happen when the continuous sync is turned on. Now, keeping in mind that you might have a requirement to not sync all the discovered CI details into the CMDB, and maybe for that you are not keeping the continuous sync turned on. In that case, you need to make sure that you are searching the destroyed CIs in Discovery and manually syncing them into the CMDB so that Discovery can send mad equals to yes flag on the destroyed CIs in CMDB. I have listed down one query here in the walkaround section that you can see is going to search for all the host type of CIs which are destroyed in Discovery. And from the search output, we can click on action and sync to CMDB to sync all these destroyed CIs in one go so that they get mad equals to yes in CMDB. Once the mad equals to yes is set on the destroyed CIs in CMDB, you can run the purge job, which is then going to hard delete all those CIs from Discovery import dataset. To avoid these type of problems, it is recommended that you keep the continuous sync on if you don't have a specific reason to keep it off. The next common issue, which is duplicate CIs in Discovery import dataset, is a very frequently reported problem. So let's talk about the probable root cause for this type of issue. The first probable root cause is that you are keeping the continuous sync off. And this could cause the duplicate CIs because if a CI is destroyed in Discovery, Discovery will not send mad equals to yes on that CI in CMDB, and that CI will not get destroyed when you are running the purge job. And if the same CI is rediscovered in Discovery, Discovery might create a new CI in CMDB. So you will end up with two identical CIs, one from the previous sync and one from the sync that happened after the CI has been rediscovered in Discovery. So again, the recommendation is that you keep the continuous sync on. The second probable root cause for duplicate CIs are that two or more Discovery appliances are syncing the data to same Discovery import dataset on the same CMDB server. In this case, if the Discovery appliances are discovering overlapping CIs, then they will create duplicates in CMDB. So the key takeaway from this is that at a time, one Discovery appliance is syncing the data to a Discovery import dataset. The third possibility is that Discovery and CMDB integration user does not have the required permission, and because of that, Discovery is only keep on syncing the same CI again and again because it is not aware about that whether it has created the same CI in the past or not. To avoid this error, make sure that the integration user is having the permission that we discussed. That is, it is part of a CMDB group which is having CMDB data change all role. The fourth root cause is, though you are having duplicate CIs in CMDB, only one of them is active and other identical CIs are having mad equals to yes. So these are not exactly duplicate, because once a CI gets mad equals to yes flag set, then that CI needs to be destroyed or hard deleted by running the per job. So the key takeaway from this root cause is that you keep on running per job, and whenever you see duplicate CIs in CMDB, make sure to check this mad flag whether it is set to yes or not. If you're not sure how to check this flag, let me quickly show you. Log into the CMDB portal, then select the dataset and go to the CI respective class. Open the problematic CI and then click on show CI details, and from the details just look for this flag, mark as deleted. If it is not set to yes, that means CI is active. If it is set to yes, that means CI has been destroyed in Discovery and Discovery has sent the yes flag on this particular attribute, and this CI now needs to be hard deleted using the per job. Now let's talk about the next common issue, which is error instance not found when running normal sync or when running resync. The first probable root cause for this issue is that some user or process has deleted the CI from the Discovery import dataset. To fix this, if this issue is happening for a few number of CIs, then you can destroy them in Discovery and rescan them. This way, Discovery is going to recreate those CI into the CMDB, and that is going to fix this particular problem. But if this issue is happening for a large number of CIs, then consider running a full resync. However, if this error is being reported while running the resync, which is supposed to be fixing this problem, then the probable root cause is that there are some data issue or corruption in the CMDB itself. You can search the problematic CI and see whether it is available in the top class or the root class, which is BMC_base element, but not available in the subclasses. One example would be if you take a computer system CI and search that in the base element, you are able to find the CI, but when you search the same CI in the computer system class, you are not able to find that CI. That's a data issue within the CMDB, and to fix that, contact BMC CMDB support team. The next issue is violates relationship cardinality error being reported when you are syncing CIs. This error is reported when Discovery tries to create a relationship that violates the CMDB cardinality constraint for that particular relationship. One example would be trying to create a relationship from one VMware virtual machine to multiple ESX server. As we know, at a time, one VMware virtual machine should only be connected to one ESX. But if we try to create a relationship from the virtual machine to multiple ESX, then this type of error will be reported. If this issue is happening on an appliance where you have custom sync mapping patterns, then you can disable those patterns and check the sync behavior. If still the same issue is reported even with just the out-of-the-box patterns, then the recommendation is that you contact BMC Discovery support team for further analysis. Now let's look at the references. I have added a reference to the part 1 of this webinar series and to the knowledge articles that we discussed or referred in today's session. Here is the summary of what we discussed today. We started by understanding what type of discovery data gets synced into the CMDB. Then we talked about valid and invalid data inconsistency type. We discussed troubleshooting approach and tools. And for two of the troubleshooting tools, that is synchronization logs and shadow copy, we had a detailed demo. We then talked about how to customize discovery to CMDB integration. And finally, we talked about the common issues that you might see when working with Discovery to CMDB integration. With this, I'm concluding today's session. Thank you very much for attending.